this video, I'm going to show you how to do a localization, or as some people call it, a site calibration in your Leica CS20. So the localization in your Captivate software and SmartWorks is known as a one-step, and this is basically a transformation of a GNSS measured data to a local coordinate system. Just note that should you do a localization or a one-step with a base and rover and change to an RTN network, that you would need to redo the localization. The localization can be done either way, base and rover or RTN, but they're not interchangeable if you were to change the system on how you are surveying. Alright, so there are two different ways that we typically can attack this, and I'll show you both ways. So here is option one, and as I said, there are two different ways to attack this, and it will be up to you to determine how you feel comfortable in setting up your localization. So the first way is taking a survey or setting up a job and doing all your GPS or your GNSS measurements in that project, in that job. Taking a new job and importing an ASCII file, or a coordinate file, and this will be used pretty much just temporary as a reference file. So if you look at this particular job that I imported my data, I have all my control points that were imported as an ASCII. So they're editable. They're measured. They were actually measured on the ground in a traverse, and in CAD they were adjusted, translated, and balanced. So if you want to take a quick look at what they look like, here's my project site, and what we did was we actually ran a boundary traverse around the perimeter. So this project is nothing more than just an import of coordinates. This job is nothing more than just raw data measured with GPS. And as you can see, I've got basically just latitude and longitude. If I go to my properties in the coordinate system, I have none, which is just WGS84. You can assign a temporary coordinate system like a state plane coordinate system if you want, if you actually want to see values or coordinates, but when you actually do a one-step or a localization, it's not using those coordinates, it's using the latitude and longitude. I set it up this way for two jobs because it gives me the ability to salvage or protect or store the survey data. You have an option of starting a job, for example this one, which I'll show you later, where the coordinates were imported and then the measurements were done in the same job. And the reason why I like this method, where these two are shared separately, is for this particular example, the survey was done with our unadjusted survey data, and it was done just to kind of get going. It was kind of based on recon, help us kind of walk up to a point to see if it was there, dig for it without having to set up and stake it out. We were able to kind of do a recon system. So first time we did a localization, it was based on a 5,000 coordinate system. After the traverse was balanced and rotated, it was moved to another coordinate system. Because the coordinate system changed, I didn't need to resurvey it because I have the survey. The survey is here. So all I'm doing is basically throwing out the old coordinate system or the old ASCII file and starting a new job and bringing that in. and then redoing the coordinate system or the one's localization based on my new coordinates. And if you were to do it this way, if you were to change or adjust or change the coordinate systems, you're overwriting coordinates, and it just becomes very messy and questionable on what you're overwriting and what you're deleting. So this way, like I said, you know, it's a way of protecting this is my survey. I'm not importing any data. I can change the coordinates later, and you know, this way is not. So all right, so as I showed you, here's my data. And it says northing, easting is blank because if I hit edit, there's my values. Okay, so now we're going to create the localization. So we're going to come to the Create Coordinate System app. If you look through here and you don't have that app visible, just roll over to the Settings, Customization, App Visibility, and scroll down till you see Create Coordinate System. If it has a slash through it, it's not visible, just uncheck it and hit OK. Now you should have a Create Coordinate System app. So method, Onestep. So we're going to use a Onestep for this type of localization. Let's name this. So when you name it, you want to be able to come up with a name that makes sense, something you can relate the job site to all future jobs that you create. So if you called this GPS or you called it localization, you won't know, or if other surveyors come on the site and you share your coordinate system, they won't know that this coordinate system is this particular site. So try to identify the site that makes the most sense to its name. So in this case, let's just call it Site A. We'll call it GPS. Site A GPS. All right. So where is the data that you surveyed? So your WGS84, that's your GNSS or your GPS data. So I'm going to point to that local GNSS. That's that job that I did the survey in. Where is the local points stored? That's that job I created where I imported the control file, and I created a job and imported just an ASCII file, which is just my control. So we're not doing a one-point localization, so we say OK. All right. So height mode, we have two options, orthometric or ellipsoidal. You want to pick orthometric if the site has a known datum. If you came off, or it has a datum, put it that way. If you use an assumed benchmark on point 1 of elevation 100 and that's the way your survey is, then you have a datum. So in that case, and that's a local datum, so we're going to say orthometric. If you got nothing to go with, and you can use ellipsoidal, but you've got to use a WGS84 ellipsoid. You can't use a GRS80 ellipsoid because that's not the same. That's for state plane. So as long as you have a WGS84 ellipsoid to reference, then you would pick ellipsoidal. The two combined will get you your ortho height. But if you have a known elevation that you're using, your control is based on a town benchmark, an NGS monument, or even an assumed, go with orthometric. Geoid model, again, we're not using any geoids, so that says none. All right. So setting this up. When you measured your survey in your GNSS or your GPS, you have two options. You have a known control point, or traverse point number 3. You can survey this in GPS and call it 3 as well. Or you can call it 3 GPS, because you got a 3, which is your ground control, and you have a 3, which is your measured. And if you set it up where they're the same name, and you hit auto, it will automatically say 3 to 3, 4 to 4, 5 to 5, 6 to 6, etc. If you have 3 equals 3 GPS, then you will need to do them manually, and I'll show you how that works out. So if I hit auto, If I come to here, these are all my measured points that I showed you earlier, and you can see if I go to edit, that 3 from my WGS84 survey, which is here, my local GNSS, and 3, which is my local control, and here's the coordinate. So there's the coordinate we're going to be matching. I come to here, and I go to 3, and more. There's no value. That was the, remember I showed you the Latin lawn. Okay, so 3 and 3 can be measured, and for now we're going to go ahead and say position and height. But I know that I have a 0.1 and 2 that were shot as well, but they don't show up in this match, right? When I said, oh, I'm sorry, when I said auto. So I'm going to go ahead and I'm going to hit new, and I'm going to say, okay, I'm going to pick, yep, GPS 1 is to be matched with 1. I'm going to say okay, and I'm going to say new, and I'm going to say 2, and I'm going to say 2, and I'm going to say okay. So what I've done is I've done these manually, and some people prefer to have their survey separate. This is where it benefits to call them the same number again. 3 is 3, 4 is 4. So when you hit auto, boom, they automatically will do this for you. So after I've done a quick check, I'm just going to go ahead and hit calculate. I'm going to look at my numbers, and I'm going to go, oh, they look pretty good, but I got an outlier up here. I just saw it. There it is. I got an outlier. Height is way off. I'm off 4/10 in the north. I'm sorry, I'm out 8/10 in the north, out 4/10 in the east. And anything near it, which is if you think this in sequential order, 16, 17, 18, 19, 20, by this pulling it to the 8/10, what's happening is this is influencing all the others around the area. So this 19 is out by 1/10. This 20 is out by 1/10 in the north. The east thing's out 9/100. So you can see that this 18 is kind of an outlier. So what I'll do is I'll take a look at it and I'll say, you know what, let's go ahead and if I go back, I'll look at 18. I'll go, you know what, let's just say match. I can say position only, where height is not part of this equation. Or I'm going to say, you know what, none. I'm not going to hold the height, and I'm not going to hold the horizontal position. So I'm going to run calculate again, and I'm going to just start looking for any more outliers. And I'm going to look for them in horizontal, and I'll look, or I can do all the horizontal first, and then go back and do all the vertical if I want. So I look at the outliers and I say, okay, you've got exclamations because my parameters are set so low. I have to determine whether I feel that 400ths is worth keeping or getting rid of. Don't forget, by this being taken out, this 2 may change. If you remember, we were at 18, we were at 900ths or 1/10 in the north. Once 18 was taken out, this whole transformation was shifted a smidge just to get, now look how good the 19 works. 500ths, you have to determine whether you feel that's usable or not. All right, so I look at this and I go, 200ths, 500ths. So maybe, you know what, maybe 19, I want to take, that seems to be the worst one also. Now I've got 16 and 20. And if you actually know this position in your head, you may know that 19 is a corner of where we actually changed directions and went up a side street. So the question is, should 19 be the furthest point of the projection? But we can go ahead and take it out, come over to 19. I'm going to go with position. I'm going to go with vertical only, calculate. So 19 was good for vertical and height, but now you can see how the 20 all of a sudden becomes a little better. Ooh, 21 seems to be a influence, so I'm going to take out 21. I'm going to say position only, calculate. So you start going through these numbers and you want to tighten it up. Now you got to remember that the more you exclude, the smaller your envelope is. So if I had if I had Traverse Point, GPS 1 and 2 in the north, and 18 and 19 on the south, and 16 and 20 are kind of the southeast and southwest. Now 16 to 20 is now the southerly side of the envelope. So you got to remember, when you start excluding points, you want to make sure that you exclude points that are don't shrink your envelope. Heights are the same way. You don't want to have hold 5 points, but they're all the northeast corner. The 5 points all, a couple hundred feet apart. Because you held 5 points, you feel you've got a good localization. These heights should be balanced. So I'm going to say OK, and then I can look at my my summary. This is my east and north of my height transformation. I'm holding 20 points. That's what I wanted. I wanted results. So I can look at my height. I can look at my slope. So this is my slope and my X and Y. This is kind of like a scale factor. The closer to 0, the better. If you had numbers up here, you'd obviously have a pretty big slope. Okay, and I'm going to look at those. If I want to look at scale factors, I can see what kind of scale factor I'm dealing with. And say OK. And if I decide that this is exactly where I want it, I'm going to say OK. Site A GPS, store. Now, if I look at my coordinate system, and I go to properties, Site A GPS, store, and I look at my coordinates. Now when I go to elevations and coordinates, I actually have values now. This is based on the localization. Now when I start a new job, I can reference my new coordinate system, and now I have the localization that I did here is now attached to this job. So when you send this job to a fellow field surveyor, he will get your localization. He may not be able to edit it, but he can at least, it's part of the job now. Alright, so let's assume that now you've done some checks and you feel you need to make a few minor adjustments. Maybe you shot another point or two. Maybe you feel that one of the points you're holding vertically could be shot incorrectly or poorly with the GPS, so it should be excluded from your localization. So you come in and you need to make some changes. So let's go to coordinate system, and this time instead of one step, we're going to pick modify existing. We're going to say OK. We're going to pick the localization that we created. Say OK. Make sure it's pointing to the right correct jobs. Alright, so now we're going to just take a look and we're going to say, what could be the problem? Okay, you know what? This elevation should be taken out of the equation. So we're going to say, okay. Going to come over to 12, and we're just going to say, position only, calculate, and like I said, we can say okay, and we can add a new point if we want to add some points. This is the time to add some new survey data. When we're all done, just to calculate, okay, and it will just basically reprocess and overwrite the coordinate system. So the coordinate system is still known as job A, nothing changed, but basically your GPS data is dynamic, so as you change the coordinate system, the values will change automatically. If you had done this on the ground with a total station terrestrial way, your coordinates are static and they will not move. So you want to make sure you're good with your GPS before you continue. Okay, so now let's talk about an alternative way of setting up a job to create a localization. So in the previous way I showed you a method of having the survey in one job and the ASCII import in another, and then using the two to create your localization. So in this option, I started a job, imported my control file, and then did the survey inside that job. So there's nothing wrong with that. The good thing about this is I basically just take this job and I archive it, and I can always bring it back and add to it, or I can always bring it back and say, you know, what did I hold, you know, a year or 2, 3 years ago, and kind of always remember what was held once it's been localized and you've created the coordinate system. So you know, let's say it's not a con, but if you actually look at the data at first with the highest class, you don't really know what was surveyed. All you have is your highest class, which is your ASCII import. But if I actually go to function filter and change it to all, and all of a sudden I've got 0.2, 2, 5, 5, 5, 10, 10, 10. So you have these points that show up under all. But if I actually go to classes and change it to averaged, say OK, now these are all measured data. So these are all average points. So if I want to view that, now you can see this is actually what was surveyed around these around this boundary. This is what we shot with GNSS receiver. All right, so now we're about ready. We want to do a localization. Same method. I'm going to call this a Onestep, and we're going to call it job B. Or you know what? We're going to call it job A RTN, because this was done not with base and rover like the first example, but this was done with an RTN, so it has to be redone. So in this case, the survey is in this folder, and this job folder, and so isn't the coordinate file that we're holding. So we say OK. Again, height mode, orthometric. Geoid, none. I'm going to go ahead and hit auto. Again, it matched the 2 to the 2, and I know that I have a 33 GPS and a new 34 GPS. Okay, so I've got my points. Now, the benefit of having the job with both survey data, I can compare my surveyed coordinate after the localization is created to what I shot it as versus what it was supposed to be. So you know, you can get the deltas in the when you do your point and match. If I actually do a calculate, these things are all over the place. I look at these numbers, definitely have a problem in the verticals. So sometimes it's, when you look at these verticals, like, wow, there's just so many out of sort numbers. You know, this one obviously doesn't look like it belongs. This one doesn't look like it belongs. But maybe sometimes it's a little hard to say. Well, when we look at the horizontal looks pretty tight. You know, 500s here. The numbers look pretty good. But maybe sometimes you're not really sure about the verticals. So what I'll do in that case is I'll actually hold only 1 point horizontally. Alright, so we'll go with 2 vertically, and I'm going to match all these to just the position only. So position. So the whole thing is based on one height. Calculate. So I'm going to say OK. I'm going to call it job ARTN. Now, when I look at the data, and I go to function filter all, so 2, let's go to more. All right, so 2 is held. There's the number. So now look at 3. Next one, 5. So I will note that the difference between 5 and 5 measured and 5 coordinate. All right, looks like we got a decent spread there. 7 and 7, not bad there. 10, 700s there. 15, and that one's pretty good. 20, that one's pretty good. Yep, 20 there, and yep, that one's pretty good. $33. That one's pretty good. Oh, there it is, 33. Oh, so that one's, so I got a 33 that we measured on the ground, 46 and 11, and 33 GPS, 46. Yeah, that's off a 10th. You can see how my 33 GPS is kind of bouncing around as the average, but even the verticals are off. And then 34, 38. Oh, that one's definitely a culprit. So by holding this, I can actually compare to see how tight they are. If I actually look at my 3D viewer, I can get an understanding. As long as, you know, if I can hold 1 point vertically, I can check the others and see how well they are. So maybe, you know, this point is good, this point's good. Throw out that point vertically, hold that point. Let's actually look at the filters. So I want to look at, make sure I wouldn't put all the vertical, you know, here, 5 and 2. I wouldn't hold 5 and 2 because it can throw off. If there's this slope between these two gets projected and stretched out, you actually are creating a slope across the property. So there's kind of a rule of thumb when we're doing a localization that we want to hold for horizontal. 2 will get you a lock, like an azimuth, but 3 will get you residuals on how well. So if you held these 2 horizontally, you wouldn't know how well they held. It would just scale and force the azimuth between these 2. But if you held a 3rd point, now you would see a scale factor based on all 3 points and how well all those 3 points work together. Vertically can be dangerous because you either want to hold 1, or I like to hold 4 or more. If you hold 3, like a tabletop, right, and you hold these 3 vertically, it'll lock them down. All 3 will be held zeros. But the minute I bring in a 4th elevation, then you will get residuals on all 4. So what I'll tend to do is hold 1 or 4 or more vertically. And again, don't hold 4 all up in this corner if you shot 3 or 4 points up here, because by the time you get down to here, you're causing an error. So if the case was, if this was no good vertically, and I decided to hold 1 for height for vertical, and then I can see how well all the others match. So 1 or 4 or more when you're doing your localization, and horizontal should be 3 or more, and I'll show you that. So, all right, let's create that coordinate system, and we're going to go to modify now. So we've evaluated the heights, so we're going to come into our job ARTN. Yep. All right, so I'm going to 10, based on reviewing it, I'm going to hold 10. Take a look. I mean, I can take 124 out of here, depends on where 124 is positioned, but I'm going to go ahead and hit OK. Store. Now if I actually want to review my data again, points, function, filter, all. One 1705, 08. We actually got 03, 05, so we've got a couple times we shot it. That one's good. 5, 9. So we can compare the elevations, and that means that your localization is looking pretty good. So that about wraps up how to do a localization in your Leica CS20. So you have a couple of different options on how you want to set this up. I think both options, will get you the same result, but one option gives you a little bit more flexibility. But I do recommend after the localization is kind of set in stone, and this will be held throughout the rest of the project, that this job or DBX be backed up in case you ever have to expand or add to, or even go back and kind of refresh your memory on what was held. So take a look, play around with your measurements. Remember that if you are measuring a control point with your GPS receiver and your quality is not good, then the point will cause or introduce error into your localization. So you could be influenced to hold a point that is either not good, or or you may see some error and feel that it should be excluded from the survey. So understand when you're surveying that you want to create an envelope around the project, as well as get good GNSS data to use in your localization. So give this video a thumbs up and like my page. Thanks for watching.